Hey guys, welcome back to another exciting, fun-filled Algebra 2B lesson. This time we're going to talk adding and subtracting rational expressions. If you recall, in the last lesson we were multiplying and dividing. And when you're multiplying and dividing, you just multiply numerators, you multiply denominators, everything's good, everything's pretty easy. With adding and subtracting, you need a common denominator. Common denominator. And if you have one, like in this example here, that's great, because all you're going to do is you're going to just combine like terms in the numerator. You don't do anything with the denominator. It stays the same. You just combine like terms, and we get this answer here. We have, this is our example. Now, you still have to identify situations where the x value is undefined. So if you notice here, they said that x cannot equal -5 because that would make the denominator here -5 plus 5 equals 0. Subtracting, you do the same thing. You're going to group your like terms together on the top. You're not going to, there we go. You're not going to do anything with the denominator. It's just going to be the denominator, the common denominator. One thing you do have to remember, though, when you're subtracting, this second expression, in this case the 8x plus 2, is going to be, everything's going to change signs because you're subtracting. So it's going to be minus 8x, it's going to be minus 2, so you end up with -4x minus 5. And then, of course, you've got to identify your values for where you're undefined. In this case, 2x minus 1, it's going to be 1/2. So let's take a look at some of these, and let's see what we can do. Number one, they were nice enough to combine the numerators together for us. Common denominator is x minus 4. So let's see, we got x minus 5 plus 3x plus 2. So x plus 3x is going to give me 4x. And then -5, let's get that x, there we go. -5 plus 2 is -3. And then we have x squared minus 4 in our denominator. And here's its twist. Remember that x squared minus 4 is actually x plus 4 times x minus 4. It's one of those difference of squares. So x cannot equal 4, but it also can equal -4, because either one of those is going to give me, or I'm sorry, it's not 4. What am I talking about? It's not even plus 4 minus 4. Jesus. Come on, apps. All right, it's plus 2 minus 2. So x can equal 2 or -2. Because either one of those values will give us a 0 for our denominator. Now for number 2, our common denominator is x plus 3, so we're just going to combine our numerators. We are subtracting, so we're going to get 7x minus 4x. That is 3x. 3x. God, I'm having a hard time today. Let's try to erase these here. Let's see, erase. And let's go back. So 7x minus 4x is 3x. -5 minus -1. Minus minus is going to be plus 1, so that's going to be -4. And that's going to be over x plus 3. So x cannot equal -3. If you look at number 3, we're subtracting again. Our common denominator is x minus 1. So we are going to have 2x minus 1 minus 5x plus 4 over x minus 1. So 2x minus 5x, that is negative 3x. Negative 1 minus 4 is negative 5. And we are over x minus 1. So x cannot equal positive 1. Alright? I hope you get the idea. I'm not going to do these other examples. If you want to, knock yourself out. Now here's the deal. What happens if you don't have a common denominator? If you don't have a common denominator, you need to find one. You need to find the least common denominator of the two, and if you're going to add or if you're going to subtract, the process is pretty much the same. It's basically, what do I do when I have to add fractions with different denominators? Well, let's take a look at this example, okay? So if I have this guy here, right here, my denominators are not the same. So I'm going to have to figure this one out. What am I going to do? Well, the easiest way to do this is actually to factor it first. So that's what they did. If you notice here in this part of the problem, they factored. Don't have to do anything with this guy, the second term, because x minus 1 is factored already, but x squared minus 2x minus, or plus 2x minus 3 is x plus 3x minus 1. So how do we find the least common denominator? The least common denominator is actually the least common multiple of the denominators. And this is kind of the opposite of greatest common factor. It's going to be, what do they both have? So if you look at this, they both have x minus 1, but the first term also has this guy here, the x plus 3. So that's got to be included along with the x minus 1. So we have a common denominator of x plus 3, x minus 1. Put those two together, and you've got the least common denominator. And don't worry, we'll work some of these out so you understand it better. But maybe I can show you an example that's a little bit more basic. Let's say I have two fractions, like, I don't know, 2/3, and I'm adding that to 3/5. Nothing in common here between 3 and 5, but 3 times 5 is 15. That's going to be the least common multiple. So what I'm going to have to do is I'm going to have to rewrite these both with a common denominator of 15. Now, how do I do that? Well, 3 times 5 is 15, so I'm going to multiply this side by 5 over 5, technically. So like here, it's going to be multiplied by 5 over 5. This one I'm going to multiply by 3 over 3. So I would get 5 times 2, 10 fifteenths, and 3 times 3, 9 fifteenths. And that's going to give me a total of, well, 10 plus 9 is 19 fifteenths as my answer. The process is going to be the same when we're dealing with these expressions. The easiest way to find the expression is put them together. What's missing from my second rational that my first one has? That's the x plus 3. So if you notice down here, they multiply the top and the bottom by x plus 3. So we get 2x squared plus 6x, x minus 1, x plus 3. That is now, they both have a common denominator, so I just combine like terms, and I get this, 2x squared plus 7x plus 4 over x plus 3 times x minus 1. Yeah, it's kind of complicated, but trust me, you guys can do this. Now, if we look at this one here, number 7. We have x minus 1 over x squared minus 4 plus 3x over x plus 2. All right, so they factor the first one, and they get x plus 2 times x minus 2. Well, this guy here already has an x plus 2, so we're going to have to multiply the top and the bottom by x minus 2. So what I'm going to get is this, x minus 1 plus distribute 3x squared minus 6x, and it's all going to be over x plus 2 x minus 2. Now if I combine my like terms, I end up with this. 3x squared minus 7x minus 1 over x plus 2 x minus 2. And x cannot equal 2 or negative 2. Ugh. We look at number 8 here. The top can't be factored. The bottom, though, would become x plus 1 times x plus 2. And to that, we are going to add this 3 over x plus 1. So guess what? We have to multiply the second by something. What's missing? It's missing the x plus 2 from the first. So you've got to multiply the top and the bottom by that x plus 2. We'll end up with, let's see, 4x minus 1 plus distribute, that is 3x plus 6, and it's x plus 1 x plus 2 in the bottom. Combine like terms, 4x and 3x is 7x, negative 1 and positive 6 is positive 5, and that is again over the x plus 1, x plus 2. So x can't be negative 1 or negative 2. Yeah. So this is going to take a little bit of work. It's not hard work. You guys can do this. Take a look at number 3. What's the least common denominator for these two guys? Well, let's take a look. X squared minus 9 factors to x plus 3 times x minus 3. X squared minus x minus 6 becomes, let's see, factors of negative 6 that add up to negative 1, that would be x minus 3 times x plus 2. So they both have an x plus x minus 3. The first has an x plus 3, the second has an x plus 2. So guess what? In order for there to be a common denominator, it's got to have at least one of everything. So put them together, we are going to have, those bells are so long, x plus 3, x minus 3, and x plus 2. That is going to be what they all have. That's going to be my least common denominator. Now, if you look on the third page of the notes, I just gave you some more stuff there to work with to find least common denominator, some examples. Right here is another fraction example. Right here is an example using monomial terms, so we got 2x and x squared. The common denominator is going to be what they both have, so it's 2x squared, and that'd be how it's done. For example, if we're looking at the least common denominator in number 1 here, we got 2x to the 6th and 6x. So the common is going to be 6x to the 6th, because that's going to be what they have in common. Here we got 10xy and 5x to the 4th y to the 3rd. That's going to be 10 and x to the 4th y to the 3rd. That's, again, what do they both have? Well, 5 will go into the 10, and the x and y will go into x to the 4th y to the 3rd. What's the common denominator for these two guys? X minus 8, x plus 1, and then x plus 1. Again, it's going to be combine them. Combine them together. X minus 8, x plus 1. X squared minus 5x plus 6 and x minus 3. Well, guess what? That first one's going to factor to x minus 3x minus 2. So what do they both have? They both have the x minus 3. What's missing? X minus 2. So I'm going to have x minus 3 and x minus 2 as my common factor. Now, something that they do mention in the textbook but doesn't really show up in these notes is this idea of a complex fraction. A complex fraction is a fraction that has a fraction in it. And basically, it's just another form of a division problem. So here we have 8x divided by x minus 3 over x squared. Here we have x plus 3, or I'm sorry, this is the numerator, so 8x over x minus 3 divided by x squared. Here we have x squared plus 5 divided by 13 over 9x, or it can be both. What do? It's just division, right? So if I have something like this, x times x minus 1 over x squared minus 1 divided by x plus minus 3x plus 1, it's really just this. It's just a division problem. Remember, dividing is like multiplying by the reciprocal. You're going to do some keep, change, flip. Everyone needs a little KCF. So I'm going to factor, change it to multiplication, flip that second one around, cross cancel stuff out, and you can simplify. You will be doing a little bit of that perhaps tonight. And that silly train bell means we are done for the day. As always, if you enjoyed this, make sure you smash that like button, especially if you learned something, because that's really important. And I will see you guys in the next one. Thanks. Hopefully this makes sense. God, I hope so. See you later.